Day 1, Problem 1. Part A, rewrite the number into standard form. I'm going to copy down that number, 5.01 times 10 to the fourth power. Reason I left a little bit of space here is because I'm thinking ahead of what's going to happen when I make this conversion. If the exponent on the 10 is positive 4, that is going to mean to move the decimal point to the right 4 spots, and I wanted to leave some space in there for some placeholder zeros. 1, 2, 3, 4. The decimal point is going to end up here, and there'll be some zeros filled in. So the number is 501, 0, 0. Then the decimal point. Coming back from the right 3 spots, we can toss in a comma just to help us identify that number quicker. Now part B. This time the number given is 12,050,000, and the decimal point is at the end of that number. We are asked to change that into scientific notation. Scientific notation is often a faster way to write numbers when they become very large or very small. And this number here, 12 million, that's a fairly large number, and scientific notation might have been a faster way to write that number. Now in scientific notation, there is only one non-zero number to the left of the decimal point. That means we'd like to put the decimal point here so that the digit 1 is that number that comes to the left of the dot. That means that the dot needs to be moved 1, 2, 3, 4, 5, 6, 7 spots. And so our answer in scientific notation is 1.205 times 10 to the 7th power. Now, day 1, problem 2. Solve this equation. And part B, check our solution. So in part A, I'm going to copy that equation down. And then draw a line down through the equal symbol. And I notice that the variable x appears on both sides of the equation, here and here. And so one thing that needs to be done to solve it is to get the letter x on one side of the equation only. Under here, minus 0.5x and minus 0.5x. 2.5x subtract 0.5x is 2x. The minus 4 can be brought straight down. 0.5x subtract 0.5x is 0, and the 6 can be brought straight down. Okay. Now here is the x term. Next to the x term there is a minus 4. Let's remove minus 4. Add 4, add 4. The 2x comes straight down. Negative 4 plus 4 is 0. And 6 plus 4 is 10. 2 times x is equal to 10. So what must x be? How about 2 times 5 makes 10? So x equals 5. We think that the answer for x is 5. Now in part B, we can check whether that really works. So 2.5, and then where the variable x is, fill in 5, subtract 4, equals 0.5, fill in 5 for x, and plus 6. So does this expression equal to this expression? Well, 2.5 times 5, let's figure out what that is. 2.5 times 4 is 10, and then an additional 2.5 would make 12.5, and then minus 4. And 12.5 subtract 4 is 8.5. Well, that's what the left side of the equation turns out to be when 5 is substituted for x. Let's figure out what the right side of the equation is. 0.5 times 5, or half times 5, half of 5, is 2.5. Add 6. And 2.5 plus 6 is 8.5. Now, all along the question was, is that equal to this? Is this equal to this? Question? Yes, it is. This checks. And so x equals 5 is the correct solution for x.